Hello and welcome to this video about Pandas for data handling. We're excited to have you here, and in this video we're going to talk about Pandas operations and techniques. In this video we will talk about transposing and pivoting Pandas data frames. A Pandas transpose method is one way to transform the contents of a data frame to a shape where the rows and columns exchange places with each other. This is very useful to use some functions, for some math recipes, and for some analysis programs external to Pandas, for example Microsoft Excel. The Pandas pivot function extends the Pandas transpose function and provides extensive functionality for creating subgroups and mappings of variables, but with certain limitations on the data used, for example concerning the requirement for uniqueness to the defined variable combinations that creates the structure of the pivoted data frame. And the Pandas pivot table functions extend the pivot function and makes us able to handle degrees of duplicate values. The Pandas pivot table function is a very complex and very powerful function, which we will take a brief look at in this video. And we will also take a look at the melt function, which can return a pivoted data frame to a form very close to the original data form. And you could say that the melt function can do a pivot function backwards by adding certain information which is lost while pivoting. Alright, now we'll take a quick detailed look at these functions and the returns which they produce when used on a Pandas data frame. And the first transpose function simply shifts the columns and rows in a data frame. And if the data frame is uneven, like a rectangle instead of a square, the transpose function will change the shape of the data frame. And if you have mixed data types, it will result in a data frame which is returned with the object data type instead of the data types which the object had before the transpose function. So this is important to keep in mind. And the second pivot function in this PowerPoint is mainly used for creating subgroups, mappings, and transformations of selected columns or the index. And the selected columns or index form the axis of the returned data frame. And this data frame can be very helpful in making comparisons of subsets of the data frame. And the pivot function may turn rows into columns and columns into rows based on selecting the index column, selecting a columns column, and selecting a values column. And we may select a column to be the index of the new data frame, and this index column contains the row labels of the resulting data frame. And we select the columns that contains the labels to be used as column labels of the new data frame. And each unique value in the selected columns become a new column in the new data frame. And this creates a column versus column combo uniqueness requirement whose non-fulfillment may throw errors. And we may select values, a column whose contents will be used as the values of the new data frame. And as a consequence of the uniqueness requirement, the pivot functions are mostly used for statistical or economical, or you could say finance tables. And any automated function which uses the pivot tables would need code to handle and catch errors from the non-uniqueness of the column versus column combinations, because otherwise you might have a crash, for example, or that the code throws an error which freezes the computer or something similar. So this is also important to know and to handle. And the third pivot table function extends the pivot function to non-unique data items and data aggregations. So you could say that the pivot table resolves most of the issues with the pivot function. And the pivot table function also functions across many columns, so you can select many columns as compared to the pivot function. And the pivot table function is exceptionally powerful and creates flexibility plus complexity. So with the pivot table, you select the columns you want to use as the index, the columns you want to use as index, and the columns that contains the values you want to use with, for example, an aggregate function, which could be very simple, such as a sum or a mean or an average or a median, or it could be something complex as a dictionary of functions. For example, one functions for each case or whatever that case could be, or it could be different functions for different parts of the resulting data frame. And it could be many things. It could be complex functions. And as a complex of this powerfulness, this flexibility, and this complexity, many people say that the pivot table is complex, and some of these people might say that it easily could become too complex. And to symbolize this, we have a image from Disney's Fantasia. But in reality, there is no grand old wizard, but only the leadership to consider. So this is important to have in mind that these pivot table functions easily can grow in complexity in unexpected ways. And when you add new data to the pivot table, you could get surprising results as a result of this complexity and flexibility. And the fort melt function has some capability to return a pivoted data frame to its original form, or we could say a form similar to the original form. And we can say that in the usual or normal case, when you use the melt function, you have to feed the melt function external data in order to successfully replicate a pivoted column. And this is because a lot of information is lost when you pivot a data frame. And when you use the melt function, you select the columns you want to unpivot, and you may need to select identifier variables and, for example, provide data on variable names and similar items. All right, now we'll type some code, so start up your code editors. All right, having started our Jupyter Labs notebooks, we will now type some code. And on this screen you can see that some code already has been typed. And this code you can download from the course's web page as a resource. And this code will create a car sales data frame, which we have extended with 2 more sales places, plus the rating and target columns. So here you can see that we have a rating column and a target column added to this data frame. When we use this data frame, we will have 2 useful instances. The first is the car sales data frame, which is the basic data frame, and we have car sales free, which is the extended data frame. And we will begin by importing the Pandas library. So we type import pandas as pd. And we will print the car sales data frame. And we will run this code. And we will use these print instructions to check that the data frames has been loaded properly. So let's run this code. Here we can see our car sales data frame. and it has been loaded properly. And we can see our car sales free data frame, and it has also been loaded properly. And here you can see a difference, that in the car sales data frame we don't have a named index, and the car sales free data frame has a named index and some duplicates. And the first thing we will do is that we will show the Pandas Transpose function. We type car sales 4 equals car sales 3 transpose, and we print the car sales 4. So let's run this code. Here you can see that the car sales free data frame, which is this data frame, has been transposed. So here we have 1, 2, 3, 4, 5, 6, 7, and 8 as columns. And as rows, we have Mercedes, Ford, Tata, Renault, rating, and target. And the transpose function has the property that if you use it one more time, it will return the data frame to its original or near original organization or state. We type using the transpose function one more time, returns the data frame to its original organization or state. We type car sales 5 equals car sales 4 transpose, and we print car sales 5. So let's run this code. And here we can see that the car sales 4 data frame has been returned to its original state as a car sales 5 data frame. And as you can see, the data frame has been restored in the same order and with the same index labels. And now we will show the pivot function. We type car sales 6 equals car sales pivot, and we set the index to be sales place name, columns to be rating, and values to be Mercedes. And we print car sales 6. So let's run this code. Here we can see that we have the values from the Mercedes column printed, and we have the rating column as columns, And we have the sales place name as rows or index labels. We can use the pivot function with two columns. We type parsales 7 equals parsales pivot index equals sales place name columns equals rating value equals Mercedes and Ford. And we print car sales 7. We could say two value columns. We add values. So let's run this code. Here you can see that we have a Mercedes column and we have a Ford column, and that it is split on the ratings. And this is not the full standard use of pivot tables, but one way to use pivot tables, for example, to create a set of indicators for variables. We will type that the pivot function works best or is most commonly used with categorical variables, but beware of duplicate entries. The pivot function currently doesn't tolerate duplicate values. And this is important to remember because it throws an error currently if it has duplicate items among the variables. Now we type car sales 8 equals car sales pivot, and this time we set index to be the target variable, columns to be the rating variable, and values we set to Mercedes. And we print our car sales data frame. So let's run this code. And here you can see that we have what is commonly believed to be the correct or the perfect use of a pivot function. So when people say that they use the pivot function, this result is usually what they expect from the pivot function. And here you can see that our car sales data frame, which is this big originally, has been reduced to a print or an aggregation of these two columns and the values from this column. So 18 entries has become 6 entries. And this is very beautiful when it works as intended. We can type that this type of table creation is usually what is expected from the pivot function. But these examples show both why it is most Pythonic to try to keep the record data form, which is the original car sales data frame in this example. We will try the pivot table function, which is similar to certain Excel functions, but much more powerful and flexible. Or you could say that it has more options and ability. We type car sales 9 equals car sales 3 pivot table values equals Mercedes, Ford, Tata, Renault, index equals rating, columns equals target, agfunc equals sum. And we can print car sales 3 and we print car sales 9. And this will be very interesting. So let's run this code. You can see the entire car sales 3, and here you can see that it has been reduced to a column of sum. And in this case, for example, if we check out Tata, we can see that it has 3 no's, and these are all on the low rating. So if we enter the Tata column, we go and we find 3 no's. So if we check, for example, the Tata column, we have 3 no's on the low rating. So if we enter the Tata column, we have 3 no's. low, low, and low. So here we can see that the ag function has added all these three nodes, which is one on every sales place, which also has a low rating, and put them all into this column. And similarly, we can look for 9 yes with a high rating, and they seem to be all in one sales place. And this example shows how incredibly useful and powerful this pivot table function can be when properly used, as in this example. We can type, this example shows how useful the pivot table function can be for creating aggregate figures of tabular subsets. And now we will try to backwards with the pandas melt function. So let's start with the simple par sales A data frame. So we type print par sales and we print par sales 8 data frames. We create a car sales 10 data frame by using the melt function, and we use it on car sales 8. And we set the value vars to high, low, medium. Value name equals Mercedes. Print car sales 10. So let's run this code. Here we can see the original data frame, and here we can see the car sales 8 data frame. And this is the Mercedes column. You can see that we to some degree has managed to restore this data frame to a near original form, but we have failed in some ways. So we need to add something to this data frame. And what is missing now is the target variable. So we will cut and paste this code, and we will try again, but with an idvar added. And we must make a little change to the data frame before we can restore it to its original form. So we type car sales 8, reset index, in place equals true. And this will turn this index into a variable. And this will make it possible for us to use the Edwards setting and restore the data frame to its near original form. So let's run this code. And here we can see that we have almost restored our data frame to its near original form. And what remains is to name the index labels. And we can also see that the Mercedes variable is correct per row, but that it has been sorted differently. And this is important to think about when you make a pivot table, or just uses a pivot function to use a simpler pivot table, you lose some information. So in this case, you have lost the index labels, and you have lost the order of the rows, and you have in this case lost the Mercedes variable name. And you need to supply the melt function with these missing data in order to restore the data frame to its near original form. This is important to keep in mind when you use these pivot tables, because some persons, they just save the pivot table and they drop the other information. And this can create some extra manual work if you need to restore the data frame to its original form. So usually it is best to keep data on the record form. And we can say that to sum it up, it is easy to create abstract data forms, and it is easy to lose control of specialized such data structures. And this is important, and the solution is to keep it simple and use reliable functions. Alright, in this video you have learned a lot about the fundamentally useful Pandas transpose, pivot, pivot table and melt functions. And these functions are powerful and flexible functions for reshaping and transforming the data frame. They take some skill and knowledge to use with ease and comfort, and the guiding word should be simplicity when using them. In the following videos, we will extend your knowledge about Pandas functions, and we look forward to see you in the next video.